This one, you hear me? This better, I think. Yes? Okay, okay, solid. Nailed it. Okay, so good morning, everyone. Buongiorno. Just want to say before we start, I want to thank Luca Blogger here. Where is he? Luca Blogger here for helping us have this workshop. For offering to host it. It was a bit last moment because we were supposed to go to Belgrade, everything was booked. It got a bit complicated, we're very sorry about that. And we're really grateful, Luca and your colleagues here at the University of Perugia, especially Jacopo here also with us. Jacopo is here with us. Jacopo went to show me his department on Monday, and it's the civil engineering department, specialized in hydrology, and I'm using also Earth observation data for monitoring, especially irrigation systems. So very interesting work. His colleague Francesco also, and Andrea also here is now with us. Andrea, he's outside, but Francesco is not with us. But so thank you so much for helping with all this, and we'll have, as I said, a full program, and we are going to be in video recordings and to stay a legacy. So it's important to do for this size of project. I think it's important to do every year meeting so everybody can connect and collaborate, and we dedicate time really to do what we call a co-development. We have exciting keynotes also. Greg Milczynski from Synergize, Johannes Reiche from Waag University, Stefan Fritz, Martin Hengl here, Professor Martin Hengl. So we're very excited to do very interesting talks, and you can access the program from the workshop page, so you can see what's coming up, and you can then choose whether you go to the, or else you go to the training sessions. This project, if you're not familiar with it, we call it OEMC, short and open infrastructure, bit more than 12 million. And we have still 1 year to go. So last year is actually the most exciting because you finish a lot of things. And so it's really the most exciting time coming up. We just decided to extend it for 6 months. So it's not what you see July 2026, but it will be more like sorry, I wrote September, actually, December 2026. So we extended for 6 months. And the last workshop was here at Jasna, hosted by Stefan Fritz and his group. And just to give you some idea about how these workshops usually work. So we have parallel sessions, keynotes, but we also have training sessions, interactive workshops, and on the end we produced 49 videos. It's incredible actually, and these videos they registered with the DOI, so they're really legacy. They stay, and that's thanks to our team from OpenGeoHub, as you see here, Viola, Beatrix, and Guten, and also all other people from OpenGeoHub helping. We came here at 7:30 actually. So that's thanks to all this dedicated work. And so, because I usually say to people, I don't like to go to conference for tourism. I did a lot of tourism, and I prefer to do tourism with my wife, not with you guys. So, we are very different. I think we really record, and we keep things so they become also legacy. The OpenGeoHub project is quite transparent now. You can follow all the channels, all the data we produce, software we have on GitHub. We'll probably move to code very soon. We also developed the central app. We can find all the data sets, and we also have on Zotero all the publications. Zotero, if you look at the moment, there's 68 research articles. And because we have still 1 year to go, my estimate, we're going to make more than 100 articles in this project, most likely, very good chance. So it's a very exciting, so there are not so many projects that make it over 100 articles for Horizon Euro projects. And so this author page, you can also download some clippings if you're interested to rate. There's a lot of, we had just had a review, it's called review period 2, that's the month 36, so we had that in July, and we kind of, so many things, it's a big project actually. This project is so big, I'm a PI of the project, but I often I meet some people like, oh, they say, yeah, on your project, so yeah, I'm so into it, so I think there's almost 120 people, and and they change people in flux, they come and go. So it's such a big project, but we're trying to really write down all the things that we achieved, and we try to kind of make just on the one slide, It was very difficult, I think. So, but we said, let's try to put it on one slide, something we're really proud of, And so we wrote these things. I'm not going to go through all these things, but you can see there's a lot of data sets and important publications. There's some discoveries made. There's also communities being built from scratch. So that's kind of something we're proud of. Also, what I'm personally proud of is that when we made this reporting period 2, we work, almost 60 plus people, we work together on the same file. One file is had 336 slides, and we work on 336 slides together, and we prepare something that it looked very good, when we presented, we had the dry runs and testing, but when we presented, it was very synchronized, and it looked like this project, it's a one thing, and these guys are really organized. So I'm really proud of that. That's a really big achievement. Have you ever seen a slideshow presentation with 340 slides? Well, now you see. Then we also, at OpenGeoHub, we're blessed that we got this copy of Ramsar. So we have it in our infrastructure, and we've been processing it. And this is one of the, I emphasize, it's because we contribute about 1.4 petabyte of data, and we produce these global mosaics of Landsat. So they look like this. So they're cloud free, they're completely consistent, and the result is actually better than we expected. And so you have, and it's a big monthly, so you can go from 2000 to 2024, so 25 years. You have this big monthly Landsat bands and what you call analysis ready, so you don't have to do much work now to prepare it. You can just go and do some analysis and modeling. And we use this data for many publications, and also we just tested it. Let's just make the whole world into one image. It's very interesting. You just basically make a mosaic 30-meter whole world, and the file is about 134 gigabyte. So it's a one GeoTIFF. It's a 134 gigabyte GeoTIFF. It's a 1.4 million by 500 million pixels. But because it's a core, you can just drag and drop it in QGIS, and it will work. I can show you that on my laptop. Just drag and drop it, and it's as easy as it gets. And you can immediately start doing modeling and analysis in QGIS. And so there's something we're really proud of also. So there's this work one. There's about 1,500 files. So these mega files, and in total it's 120 terabyte. And we went and requested support from the European Commission, from REA, and they were very friendly. They called the European Space Agency, and this data is now available in Copernicus Data Space Ecosystem. So it's not only just our infrastructure, so now it's really big. So now this data is going to be available to anybody using Copernicus Data Space Ecosystem, which is the #1 infrastructure for Earth observation in Europe. They're going to have access to this. It's not today available. It's going to be made available on Friday publicly. And so we're very excited because we can really celebrate here at this conference, at this workshop. We can celebrate that this data is now available publicly on CBSC. So I'm really proud of that. In the meantime, this summer we were busy. So we are doing the version 2, because the version 1 was a bit monthly. So we're going up to a monthly version, and we're doing a full reconstruction. So it's not just the gap filling, but we really want to reconstruct the signal, and we find the algorithm, we find a method which is based on neural nets, so deep learning. It's called CFC, continuous time neural networks. And we got the results already, and soon we will have also, and this is actually better quality, of course, it will be also better compressed, but it will be monthly, and it will be about 400 terabytes. Hopefully we can reduce the size with the better compression. And this thing, hopefully by the end of the year, it will be also on CDSC. So I was also on the Global Geo Forum in Rome, and they use it as a use case for CDSC. It is a very good system, and by the way, when CDSC, when our project started, CDSC didn't exist, so we didn't have no grant agreement, we had no mention of this infrastructure, so we kind of adjusted on the go. And also it's a really nice that these things are evolving now and things are really happening. So it's really exciting that Europe has now a serious infrastructure to host the data and to provide these computing facilities for anyone really. Another workshop in Krakow, highly recommend Copernicus Land Monitoring Services. I think they do once a year, General Assembly. More focused on users, exposing new data. There also the CLMSC is also moving to the CDSC as far as I know. So that's also very exciting. So it will all be at one place. Copernicus Land Monitoring Services, that's something like USGS and NASA's infrastructure for Earth data. So that's a European version because they're more like they make these products, analysis products. Then we also made a terrain model. Here, my colleague Yufong, and he's going to give a workshop. Actually, he's not here now, I think he's outside. But he's going to give a workshop on that and how you can use this next generation terrain data. It's not just a terrain model, but there's also 15 terrain variables. We are working also on sample and cover. We find a way to do a combination of global and regional sampling, and also very exciting, but there are some delays with that, so this is not yet ready, but it will be probably end of the year also we will have that ensemble and cover finished. Then we had also recently paper on the median vegetation height, also 25 years, for every year you can see now median vegetation height, so it's not the top of the trees, but it's kind of like the density of trees, and it's very good actually to map for the short vegetation, so it's adjusted for short vegetation. And you can see that we have for each of these predictions, we have also here, we have uncertainty bands, so we also know where there's an uncertainty maybe higher or lower, so we provide that together with predictions. And there's a publication also, you can see, you can read it. And so you can see this data set. It's you can compare some areas, and you can see when there's a transition of land cover, it has an effect also on this median vegetation. So there can be some breakpoints. And now this data is available publicly to everyone, and we have it on our open land stack. And probably it will be also made available probably to 3DSC. Then this is the example of this median vegetation height. It's quite amazing, it's when you have like 25 years, you can see like this is a area in Brazil, I think. You can see conversion of land and deforestation. So it's really, really fantastic to be able to have the data, and you can now look at also trends, you can see where the trends are steep and where the trends are gradual, because it's not just the land cover change. Sometimes we have a forest like slowly disappearing, there's some land degradation trend. Then we have the colleagues from Vaca University, they made this deforestation drivers and connecting that. So deforestation drivers with all these crop types and cash crops, etc. And also fantastic work. There's also a new version coming, I think, global data set. And they did it at 5 meter, I think now it's 10 meter, new version. Synergize with the planet. they made this 51 million field boundaries, they made the data open, so the data is accessible by also, you know, it's people criticize it, some people don't know it really doesn't match anything. But nevertheless, to have like a 51 million polygons, you know, produced purely from vertical duration data and made available on the model, it's really fantastic. It's a fantastic step, you know, it's not nothing that we had before. And we already integrated this into the regulated tool for European data, etc. And people are really excited. Also the colleagues here from CNN, they work on the operational ground monitoring in Europe. A couple of data sets coming out in publications. It's a pan-European product. The colleagues from the ETH Zurich, they made a global 20-meter leaf vision X-factor and fraction of color vegetation products from Sentinel. High quality products, also publication. You can explore this data in Google Earth Engine, and there's a little app. You can compare things, you can zoom in 20 meters, it's really fantastic resolution. And so that's also big achievement, and very happy. Felix is, I think, somewhere Felix. I think he's has some delays, but so he can talk about it when you see him. He can talk about this, and you can ask him. And then we just had 2 weeks ago we had a summer school, EU Data Science summer school. It was 6 days and also almost 50 videos. Everything is already available. You can watch the videos. And there's a lot of things happening now. The things are really speeding up. There's a lot of AI technology coming and new solutions, new products. Things are really speeding up. I see also from the Living Planet Symposium in Vienna. So what did we learn and how do we move towards impact? So the last year of the project, as I said, it's the most exciting. It will be very productive period because we're finishing many things we were preparing, now we finish. And also we will have a big conference in Barcelona, I mentioned it later. So that's probably next year September. And so that's very, very exciting. What did we learn? So we struggled a bit with the size of the data and hosting the data. The data volumes are really increasing exponentially, and luckily we have this now set up with the Copernicus, the CDSC, the Copernicus Data Specific System, and so this data on Friday, as I said, we're very happy. Friday will make it official. The data will be in CDSC, so that's the one thing we solved. We also struggle with doing global and local modeling. It's actually can get very complex because there are very different interests and settings if you do global and local. So we develop these two parallel systems and they have to be merged together. And it is possible, but in the case of ensemble and cover, it turned out to be way more work. So we underestimated the amount of work. That's why we have delays. And these are all the reasons why also we decided to postpone for 6 months, and they approved this, which are in process now, that the project will officially finish in December next year. So actually a bit more than 1 year of project life. I was in the Krakow and I took a photo of this slide. I hope they don't mind. We had, when we started the project, obsession was the ARP, analysis ready data, because we knew the way to make the data more usable is to make it more analysis ready, more easy to access, more cloud open, etc. And we don't have this term, we call it ARCO, analysis ready cloud optimized, so ARCO data. In the meantime, they said, okay, this revolution is finished. We guys in the CLMSC, now we have to focus on PRD. So that's the new paradigm. PRD, it's, have you heard of it, PRD, anyone? PRD? So this is called policy, what is it called? Policy relevant data. Policy relevant data, PRD. So you finish with R&D, say, okay, we have R&D, but now not all this data is policy relevant. So you need to make the data, which is also policy relevant. So you need to interact with the stakeholders you need to interact with these organizations, and you see what exactly do you need. And then you make a PRD. So that's a new abbreviation, policy relevant data. And I want that you leave this conference. Says, what did you learn in Perugia? I learned PRD. Okay, so it's called Revolution Number 2. And also what happened in the meantime, when we started this project, lots of Earth observation was just this raw images scenes, you know, with the clouds and all these issues. And so that was the reality of Earth observation. And suddenly Google, together with the DeepMind company that actually obtained, so they went and they trained these models and they put all the Earth observation data into like a mixer, and they produce one global, consistent 10-meter resolution data set for the last 7-8 years. It's the 64 bands. So they don't call it bands, it's embeddings. So like components, so it's like a model principle component analysis. And this is all it. So they put all these inputs, you know, the Landsat Sentinel-2, the biggest chunk is actually Sentinel-2, but also Sentinel-1. Sentinel-1 and Sentinel-2 about almost like 65% of the data. And they put everything. But they also put Copernicus surface model, the global surface model, and they have also Landsat included. JEDI, I don't know how they include JEDI, but so they have everything together, and I just made this data. It's a 10-meter, but it's completely consistent. It's ready to go, and it's cloud optimized. Of course, it's on their infrastructure ready for cloud computing, and many projects that are using. It's really an evolution of Earth observation. But people, you know, criticize it, and people also, there's also vanity and jealousy, I don't know. But also good thing in science is that other groups says, oh yeah, we want to do the same. And so now there's already a new model called Tessera. Tessera in Italian means Tessera. Tessera, sure, Tessera, yeah, so there's a car, but they wanted to do something like Terra, Tessera, I don't know. But their name is GeoTessera, Tessera, and they claim it's a higher accuracy. It's a higher accuracy, and I like this citation here. It says, our system performance surpasses Alpha Earth, which is the Google Earth embeddings, which was recently mounted Google, despite using far fewer computing resources and a much simpler architecture. So they tend to be better for less resources, but what is very nice, this is now, the model is also open. So that's the difference from Google Earth embeddings, where the models are proprietary, is actually also models open, so you could potentially reconstruct this if you want to improve. So things are, there's positive things. Then very scary thing is, as I said, things like can you really drastic, and this is Gemini and the Google Maps and Google Earth being integrated. This is happening now, and it's only the works. This is not something operational, experimental. So you can now just instead of doing any GS, you don't have to be a GS analyst. You just put some text and you say, give me this area, show me where these things are, and you will get output of analysis as a polygon, and you can then go further and start. So the AI is getting integrated, fully integrated, embedded into the geospatial data. And soon there's a chance that all these spatial analysts and modelers, they will become redundant. Also, NVIDIA has a huge computing resource, and they made the Earth 2. So it's like a second Earth, alternative Earth. So they are doing this digital Earth twin. And now they focus on weather and forecasting weather, but they have also very good accuracy, and so they can predict weather and better than many national meteorological agencies. So we had this meeting in the Netherlands 2 weeks ago in summer school, and we asked these questions, about 15 questions we asked to the audience. It's anonymous, so you don't have to worry, you answer however you feel. And we asked some controversial questions also. So we published this, you can read it from this blog post, but just very interesting things. So this AI technology, the beginning of the end of the modern analyst jobs, that was the question. And the 5 is yes, soon all will disappear, all the jobs will disappear. And it's very interesting, many people are not afraid, so it's very interesting to see, so they're quite confident. But of course, they're no. they're confident that many jobs will be replaced soon by technology, and we all rejecting it, and no, it's not me, maybe not for 5 years, but then another 5 years, and slowly we'll see many things will be redundant, will become redundant, and then is Google Alphabet evil, purely profit monopoly driven, and should we not share the should not share our data use their services blindly? This is kind of people are divided. Many people are diplomatic, they stay neutral, so very interesting. So yeah, but some people, bit more people think yes. Then there was a question, should you more invest? Because some entrepreneurs like Elon Musk and similar, they said, in the future you should stop with learning programming. You don't have to learn coding languages. They will be replaced by AI, but you should learn physics and math. So we said, should you learn more data science coding or math, physics, and series modeling? And there are, again, people are much more still enthusiastic about this. But I think many people realize you're right, if you use this Claude AI, and it's really magical. I don't know if you ever used it, but Claude AI, you can go, you just say, make a Python library that does predict the weather, based on meteo stations. And it will generate, already now you can do that, it will make with a Python library that is ready to go. Then the last one is the student. If your student does 100% of their homework using ChatGPT, Claude, Gemini, should they be sent back to school? Very, very important, it's not happening. If you have students, you have students probably, you go like, oh, my students, they don't really read anything anymore, they just go ChatGPT, I don't even know if they do any of the work, right? It's becoming very difficult to find out and follow. So very interesting result, lots of controversial questions, but also very interesting how people are divided and how this big model distribution. And some people are trying to be neutral. Yeah, also another interesting questions. Anyway, that was all super interesting. Now, this is I posted this last weekend, and the question was if an author submits a paper as an original research article, but large parts to generate by AI. Today you can write a whole paper with AI, by the way. You can have a whole paper. It will even make the concepts if you combine the Claude AI and ChatGPT or Gemini or Grok. You can generate everything, and so you don't know anymore is it written by human or is it computer generated. So I posted it on Mastodon. Mastodon is not for profit. This is LinkedIn. And look at the difference. On LinkedIn, 40% they go, yeah, okay, gray area, and 40% says, let's not worry about it. But on Mastodon, which is open source, not for profit, 97% says, yes, no discussion. So quite a difference in the distributions, right? Very interesting. Anyway, thank you so much. We expect a great conference, and don't forget, we will have also in Barcelona, in Spain, in Catalonia, next year, probably September, we'll announce it. The dates are not yet set, but already put it in your head. We are doing final global workshop. It will be very exciting, and we will have exciting keynotes and lots of people, lots of workshops. And we're going to Barcelona, a great place to be, and we'll be in a big hall that can host up to 200 people. So very exciting about that, and looking forward to the next talks.